All right, thank you so much. Yes, and this, I'd like to point out that this work is coming out of Gene's master's research at Penn State University. He just finished the MGIS program recently. The title of our talk was a shameless attempt to try to get fans of this mockumentary to come to our talk. But then when we found out what our session was and that Bernie Yenny was presenting later in the session, we really thought we should have gone with this mockumentary here instead, Waiting for Edward. And for the younger people in the audience, yes, that is Dan Levy's dad on the left there. So shadows are not always considered the best thing to have on maps. They've kind of gotten a bum rap in cartography. If we look at what shadows add to a map, this map here shows the Trefürsten region of Switzerland. The map on the left is just relief shading. The map in the center has shadows that are black. And of course, we can kind of blend those in if we want to, but it's still pretty kind of harsh and something we're not real excited about. Imhoff didn't have many good things to say about shadows. Here's something where he showed how you could start with aerial imagery, and if you worked really hard and had a lot of talent and practiced for years, you could make a really nice shaded map in spite of those shadows. But what we're finding is that shadows alone can create terrain displays that are similar to relief shading. So all of the things I'll show today are done with sky models, and sky models are a different way of lighting terrain as opposed to just using the default that comes with most GIS. And the default with most GIS is a point source illumination where there's one point of light in the sky. So each of these kind of hemispheres would represent the sky above the terrain that you're trying to show. And typically we use a point source illumination, often, as Amy pointed out, from the northwest, sometimes about 45 degrees above the horizon. And that gives us what we see as a traditional hill shading or relief shading. But there's all sorts of sky models out there that were defined by the CIE, the same people that do the color systems. And one of those is a clear sky model. That would be what the distribution of light would be on the sky on a clear day. And that includes some diffuse light in the non-illuminated part of the sky, and then the side of the sky the sun is on, you would have much brighter light. So this was the old method that came out a long time ago that I've discussed before, and that's basically just you run a whole bunch of hill shades, you have a sky model that says, okay, how bright is the light from that portion of the sky, and then it's long, it's complicated, it took a long time to run. Gene's tool runs much faster. At the same time this came out, that was about the same time Daniel Huffman figured out how to move DEMs into Blender, and I think a lot more people work in Blender because of that, because this was a pretty clunky system. But this is Gene's new tool here. The sky models are already built in for some defaults so that you can just pick one, like the clear sky from the north-northwest at 45 degrees above the horizon. And also importantly with this tool, you can choose either shadows only, shading only, or a combination of shading and shadows. So this really kind of gives us an opportunity to look at some things that were difficult to look at before. So here's an example of relief shading of the Crater Lake area, and the one on the left shows just relief shading only. It's still using the sky model, but it's only using relief shading. And the one on the right shows shadows only. So the one on the right has no relief shading at all associated with it. It's just summing up all of those different shadows from all of those different directions, and it's creating a rendering of the terrain that looks to us about as detailed as the shaded relief. I worked with Gene for over a year on his master's. I think when he showed me this slide here saying that's only shadows, there's no relief shading in there at all, I think that was the only time I asked him, are you sure? And so he put this together, of course, and this is just adding shadows one by one from 99 different directions. And that's what's shown on the left, and on the right is the accumulation of those shadows weighted by the sky model. And you can see that, it's just doing this. Based on completely two different things, the relief shading, as Amy pointed out, is based on the orientation of the terrain, and these shadows are just based on everything else around it, but somehow it all seems to come out in the wash, and just with shadows alone, we're able to create these types of displays. There's some really low illumination angles in there now. Yeah, so one thing we really note is that The shadow maps appear different in depth compared to the relief shading. So we're seeing a real difference whether you use the shading plus the shadows or just the shadows. There seems to be a little more depth there, and that's interesting. Just because if you're looking for that in your map design, this is one way that you could really go. But because of that, we also noticed that if you're trying to show vertical exaggeration, it's obviously easy to vertically exaggerate a DEM, but the visual effect that you get can be very different depending on if you use relief shading or if you use shadowing. So relief shading, Dan Coe actually showed an example of using vertical exaggeration to kind of accentuate some low relief areas, but then he did 10 other magical steps that made his maps look as beautiful as he always does. But in general, if you were just doing relief shading with vertical exaggeration, this is what you would expect. The flat areas would always stay a shade of medium gray. I actually looked up what that medium gray is called, and it's called medium gray. So I was hoping it would have a much cooler name like battleship gray or something, but it says medium gray. But the terrain facing the illumination direction, as we increase vertical exaggeration on this triangular hill, we would expect that to get brighter and brighter. And the terrain facing away from from the illumination direction, we would expect that to get darker and darker. So we'd expect changes in tone, changes in contrast, but no changes in really the map pattern of what we're seeing on the map. And this shows Crater Lake going through 10 times vertical exaggeration. And that's pretty much what we're seeing. The Crater Lake, the lake itself, is not changing in shade of gray at all because it's always flat. And the dark areas are definitely getting darker. I think it's harder to see the light areas getting lighter. But overall, what we're seeing is that medium gray on the lake, there's variations in tone, but there's no variations in the map patterns. And overall, it seems to have more of maybe the higher contrast is giving it this kind of shinier, glossier appearance. But shadows are much different. So with shadows, as you increase the vertical exaggeration, two main things will be going on. Your big landforms would get longer and longer shadows, and these things could be kilometers long by the time you get up to 5 times vertical exaggeration. And also, you would just get more and more small shadows, these small local shadows. And we can see those appearing, as we move from left to right across this. So for this example, we'll look at, go back to the Traversten area in Switzerland, and we'll start out with 1 times vertical exaggeration. And once again, this is shadows only. There's no relief shading here at all. And now we're going up through, after a while, shadows are on top of shadows, and it gets pretty dark, but that's the sort of effect that we're seeing. So what we're really seeing here is the flat areas are no longer staying just 1 shade of medium gray. Depending on how much shadow is being cast on them, we're getting variable shadows in the flat areas. The ridges are staying extremely bright, maybe too bright, because you can always see most of the sky if you're up on a ridge, so you're getting all of the brightness from all of the sky that surrounds you. And then there are a couple of edge effects here. If there's no terrain to block those areas to the west and to the north, then all the light from those no data areas is just leaking in there and making it a little brighter on the edges. It's kind of an interesting effect, but if you were actually doing this for a map, you would probably want to extend your DEM in those areas so that you can do that. And just to kind of point out one sort of other thing we noted with this is, especially if you have areas with different types of relief in it, this shadow method can really over-exaggerate the vertical exaggeration. This is an example here from Great Sand Dunes National Park in Colorado, and the mountains look pretty good in both cases. But in the case with 5 times vertical exaggeration, you really see the sand dunes themselves are being hugely vertically exaggerated and look unnatural because they're just basically casting shadows on each other in a very intense type of manner. So I think now we'd actually like to go to a live demo where Gene was going to demonstrate some of this just to kind of show you how this works and how fast it is.
Have any of y'all used a sky model tool before? Anybody? A few? Yeah? You probably got that from Terrain Tools, didn't you? Yeah? What I'm about to show you draws a lot of inspiration from that tool set. That was a Ken Field project from a few years back. And it's similar in spirit. If you haven't checked out that tool, I really encourage you to do that. But you'll find some similarities to what we're doing here. You can download what I'm about to show you here, and we'll come back to this, and we'll also put it in the Slack. So what I'm about to show you is going to use this view for making maps. If yours doesn't look like this when you like to make maps, if it looks more like this, with these icons and whatnot, you'll find that the same tools exist in both. We tried to make it kind of non-denominational in that way. So you got kind of the same set of tools that's going to be available in each. Because I'm on a Mac and there are fewer hoops to jump through, I'm going to use this view. All right. So a lot of these, as I mentioned, they're kind of similar in spirit to what you'll find in terrain tools. There are a lot of items in here that are kind of curiosities, but what we're going to talk about today is this sky model. And we're going to just pick a DEM here, and I happen to know this area already, so I'm going to pick a vertical exaggeration that I like. And just for a quick demo, I'm going to pick a lighting pattern that has few lights, about 24. And we're just going to, we've got to make sure that we're only doing shadows today. And so this is casting a light from each of those defined light sources, again, about 24 times, and then you add them up. And then what you get is this scene here. And you can see with even just that few number of lights, you can really infer the shape of the terrain. Yeah? Now you also get some of this kind of splotchy effect over here, and that's because though there are so few lights, it's easy to tell one set of shadows from another. There's a few ways to solve that problem, one of which, and the one that we're going to do here, is to brute force it. We're just going to add a lot more lights. So I'm going to pick a config that's got 200 lights, again, shadows only, and run that guy. And while that's running, let me just show you what's going on there. Those light definitions, you can create those by hand, but it's a text file that just says, run this operation with light with this set of parameters, and this is how important it is. Like we're weighting at this amount. You can create them by hand, or you can use software to do that, which is what I recommend. And you can get that tool, incidentally, as part of the Terrain Tools package. That's where I always get it. So check this out. So this is 200 light sources here. You can see that you've got a little bit more detail in the vertical terrain, and some of that splotchiness has gone away in the flat areas. It's not completely gone, but you can see that with 200 light sources, each component of those is about 0.5% of the aggregate. So each individual line there is going to be really close to the next shadow over. Yeah? And I mentioned also that this works in this other product. And I'm not going to run it because it does take a little longer to work on my hardware. But you can see you can get the same result. Incidentally, I had a couple of requests to do this on the command line. Again, all the algorithms are identical. It's just the framing that plugs it into whatever tool it is that you're using to do your map making. If you're going to do a batch process, or if you want this to be part of some kind of pipeline, you can run this from a command line and generate your shaded relief that way. Well, I said it was fast. It's kind of taking a while, isn't it? And it generates that same sort of, the exact same output comes from that. We used sample data that came from a set of kind of standardized elevation models that came from Tom's website, but you're not limited to some of that. You can even get kind of what I'm going to call less well-groomed data. I put together something here that I just got some quick data from the National Elevation Data Set. This is Smith Rock in Oregon. So as you look at this, when you add all these shadows from a lot of different directions, some of the anomalies in the data kind of pop out a little bit more. So you may have to spend a little bit more time grooming your data to make it look awesome. But this kind of looks interesting, at least, doesn't it, Pat? So that brings up the last thing I'd like to mention, and Pat touched on this a moment ago. This is kind of an interesting result visually. I think it looks kind of cool. It does, if you're not careful, it starts to look extraterrestrial. So does it fit for the map that you want to make? Well, you're the cartographer here, so you decide if that kind of thing works for you and your map. And you can also turn this into an element of a much larger system. So if you combined a lot of layers, if you followed John Nelson's tutorials on how to do that, this can be one of those layers, and it can be an interesting way to add some of the details to like a big stack like that. And I think we're out of time here. Yeah.
There's time for one question, if anyone has questions. Oh, sorry.
Thank you, guys. Really good. So this is kind of like the inverse of a multi-directional hill shade, where instead of you're doing multiple light sources, you're doing multiple shadow sources, essentially. But there's still a weighted direction of light in the end, because we still see this like northwest shading pattern. Is that adjustable in? Yeah.
Yes. So the config file that I used for that was set up to have a dominant light direction using a clear sky model. So it's apparent where the dominant light is from, but there are a lot of other light sources that fill in and create the effect of ambient light. It is configurable. It can come from any direction, or you can set it up so that there's not a dominant light source, and it's just ambient light from all sorts of directions. And then you wouldn't see like a shady side for all of those. Yes. Correct. Yeah, it's how you set up the config file. And there's a Skyloom, I think is what it was called in the original paper that Pat did with James Stewart. And also you can find a copy of that in the Terrain Tools package.